Okay, you've got your part ready for injection molding. Now you need to design a mold. Welcome to another episode. When I first got into injection molding, one of the biggest challenges I had was trying to figure out how to design the mold itself. I bought a bunch of books and went through the books, and it was a little bit frustrating because a lot of the guidance in the books was for much larger machines, and a lot of it really is not applicable to machines like these here. So one of the big things was the question about gate design. And I read a lot of things, and it was difficult to figure out what size the gate should be. Well, as it turns out, and as you will see in this episode, it's actually not that important. You have a lot of leeway in terms of how large the gate can be. And it turns out to be, in some cases, more often about cosmetics than anything else. So looking at a mold, here's a mold F, and there we go, not quite so reflective. We have where the plastic comes in, which is called the sprue. We have the runner that moves from the sprue to the gate, which is where the plastic enters into the part. So let's head to the computer and get started with the different concepts that you need to be worried about, and then I'm going to make a test mold to show some of the principles. Whenever possible, I like to start with a simple sprue, which is this part here, and a gate, which is this part here. So the sprue is what is bringing plastic from the nozzle of your injection molding machine into the mold. As to the diameter of this, it varies depending on how long the runner is going to be or the sprue is going to be. Ideally, you want it to be a little bit larger than the diameter of the opening on your nozzle. So for my machine, that's on the order of 0.1 inches. I've made this, I think, a little bit larger. This is a little bit larger. I think it's 0.13. One of the reasons I use 0.13 instead of 0.1 is so I can use a 1/8 inch diameter ball end mill to cut these slots. As for the gate, I'm using a fairly small gate here. This gate is currently going into just one side. There's no gate on the other side. Typically, I like to have the gate balance between the two sides. And then I usually start with a gate that's about 40 thousandths of an inch tall, from here to here, and then about 40 thousandths of an inch wide from there to there. Now, as you'll see in a little bit, there's no reason to make the gate this small. You can make it larger. I'd say this is the smallest you want to go. Generally, the reason I want a smaller gate, which you'll see in a minute, is to reduce the visibility of the gate after you clip it off. There are some comments that one of the things that the gate accomplishes is by restricting the plastic to a small opening. It creates some friction, which then increases the heat on the plastic, which then allows it to flow better into the mold. For desktop injection molding machines, I'm not convinced that's much of a factor because the injection pressure we have available is far lower than the injection pressure that is available on desktop machines. That is far lower than the injection pressure available on industrial machines. So on desktop machines, we're looking at probably 2,000 to 9,000 psi, and on industrial machines, it's a whole lot higher. To actually try out the difference between having a gate and not having a gate, I made this test part. This test part has a side here that has the sprue go directly into the part with no gate at all. Theoretically, this will give you the best packing because it'll take longer for this to cool and to shut off, as it's called, which is when the plastic solidifies at the opening to the part. And then I have a gate up here. This gate is about 40 thousandths from this side to the other side that you're not seeing. And then if I remember correctly, actually I'll just measure it, it's about 60 thousandths of an inch wide. So it's a little bit larger than the gate that I showed in the other example. I'm going to start out by injecting the version that has, or the side that has no gate. And it's a very short section from where I'm injecting to where the end of the gate is. I'm also starting out with fairly low pressure. So I have about 35 psi on the injection pressure. So I don't know if it's going to inject or not, but we'll have a look. And I think I'll set this to like 5 seconds to give it some holding time. And the idea of the holding time is to reduce the amount of shrink. So given how far down that went, I'm guessing it actually filled. And yes, indeed, it did fill. And I'm not seeing shrink marks. It's actually looking quite good. So the point of this is that you can fill your part without having to have a gate. Now let's go to the other side. Let me refill with pellets. And so I want to go to the side with a gate, which is this side here. Okay, and this is also continuing to move, and then holding, and then we'll eject it and have a look. And this filled as well. I also am not seeing any shrink marks, and this comes out just fine. So I think the point here is that in choosing a gate, there are more factors than just flow. One of the factors is when you have the no gate at all, it's going to leave a larger impression on the part when you cut it off. So quite often the reason for having a smaller gate is so that you have less of a witness mark or the gate mark that shows up on the part. So let me show these two side by side, close up. By the way, because of the amount of plastic, these are still quite warm, and I am starting to see a sink mark now. And these are definitely quite warm. So, when you're shooting that much plastic into a mold, the part is going to take a lot longer to cool, and I can definitely feel a shrink mark right now on both of them. So just for the fun of it, let me hold the pressure on this for a lot longer, and I'll do it with a version without a gate. The theory there is that without a gate and holding it for a lot longer should give it a chance to cool down by quite a bit more. So I'm going to set this to 10 seconds, I think. Okay, so it's finished ejecting, and now it's just going to hold the pressure for 10 seconds. And the idea there is that we want to pack this as much as we can, let it cool down so that it has as much force keeping it from shrinking, but it's still going to shrink. So the question is by how much? So again, we'll pull it out, and I can definitely feel shrink. So there's definitely still shrinkage. And this is the point I was making in the previous video. When you have something where the thickness, basically in this case it's the width, varies so much, let me get a little closer, you're going to have some shrink. And it may not be easy to see the shrink, but I can definitely feel it with my finger. The first test was using a TPV or TPU, I'm not sure which type of material this is. It's a santoprene or santoprene-like material. So it's a rubbery material. You can see it does bend pretty easily. And for the second test, I'm switching machines so I don't have to purge the plastic from the other machine. On this machine, I'm going to be using polystyrene, which is what I've used a lot. Now, the difference between TPV or TPU or whatever it was and polystyrene is that polystyrene does not flow as easily as the other material. These materials tend to flow really, really easily. So it'll be interesting to see how the gate versus no gate works on this, plus also what we experience with filling and shrink on a large cavity. Now, I'm doing both of these because generally I try to avoid a large cavity, but in this case I think it's a good test. Now to put plastic in here, I've got this tool that I got with one of my machines, and the tool is basically a piece of pipe with a handle on it that has an opening so that I can scoop plastic in like so, and then I can just let me do it from the other way. I can just tap it until the plastic starts to come out. And then I can put as much as I need into the hopper. And in this particular case, I don't want it to go to the top. This is starting to warm up, I just noticed. So I don't want it to go to the top because if you go to the top with the plastic, when the plunger comes down, it has to push those pellets away or slice through them before it can start pushing the plastic into your mold. And that can result in inconsistent shots. You want to have a repeatable process, so making sure that you fill up below the top will give you a more repeatable process. On the side that you can't see is there's a knob that I rotate to set the approximate temperature. So this machine does not have the precision of the other machine because the other machine has a temperature controller called a PID controller. So in this one it's showing that it's close to 400 degrees Fahrenheit. And so I'm waiting until it gets a little bit hotter than that, like about 450, which will be about right there, before I start to try to inject plastic into the mold. And actually what I'm doing at the moment is just purging the old plastic that was in the machine, which was, in this case, I had polypropylene, and now I'm switching to polystyrene. So I'm using a fairly low pressure, and then just pushing out the plastic until it clears up. And here's the plastic that I just extruded. You can see that it started out with the white polypropylene that I was trying to clear out of the barrel, and it's turned into the polystyrene. So I'm going to go ahead and refill the barrel and put the mold in and give it a try. Okay, so I've injected it. I didn't hold the pressure for a long time. And I'm just going to pull it out and see how it did. And it filled it nicely. So this is the version with no gate. And then I'll go ahead and do the version with the gate. This was done with about 35 psi on the injection cylinder. And it uses quite a bit of plastic, so I'll go ahead and refill the barrel. Okay, barrel's refilled, so I'll give it a go. And now I'm going to hold the pressure for a little bit longer to give it time to pack and cool a little bit, and we'll see if that makes any difference in the shrink. And that filled just as the other did. I do feel a little bit of a depression. As I mentioned before, you really can't get rid of the sink completely if you don't have a constant wall thickness. So let me pull that one out. And it's still cooling down, just like the TPU. It does take a while to cool down, but there really isn't much difference between having a gate and not having a gate. So again, as I mentioned before, it's really about how visible is the gate going to be when you clip it off. And therefore, going smaller will give you less of a visible gate, residual gate, when you clip it off. Whereas this will give you the ability to have better holding, but again, it doesn't make that much of a difference. When I model these, I model the gate and the runner as a separate component in Fusion 360. I have that component visible here so that I can summarize the learnings about the runner and the gate. In this case, we'll come back to this, but the runner and the sprue are the same thing. And then this section here is the gate. There are three characteristics of the gate. There's the height of the gate, this distance here. There's the width of the gate. And then there's this distance here, which is the depth. And so the rule of thumb is to, at least the one that I follow, is I generally make this about 40 thousandths of an inch tall. And then I typically make this 40 to 60 to 80 thousandths of an inch wide. There's really no good reason for that, but other than to try to minimize the size so that it doesn't interfere too much with the appearance of the part. And then in terms of depth, I typically make this about 20 thousandths of an inch. In this case, here you can see it's about 30 thousandths of an inch instead of 20, but that kind of points out that there's a lot of forgiveness in terms of the size and the shape of the gate that you use into your part. The next question is, where should the gate be? Now, in this particular case, the gate is not in a good location. We have the gate here where there's the least amount of plastic, in other words, where it's thinnest, and then pushing into the thicker plastic. You generally want the gate to enter where the plastic is thickest, and then push the plastic into the thinner areas. The reason for doing that is it helps with packing the plastic, and it will give you a stronger part. Another consideration for the gate location is ideally what you want to do is wherever you inject it, you want it to hit something on the other side as soon as possible. This isn't ideal because it's going to be a while before it hits that. The reason you want it to hit something is to avoid a phenomenon known as jetting. What happens with jetting is you get a thin piece of plastic that kind of shoots straight out and then it starts to curl and fold back on itself, and you end up with flow lines in that area. Another consideration with gate location, which is shown in this part here, is if you have a single gate like we have here, you want the flow from this gate location to be uniform into the rest of the part. So in other words, you want it to be able to flow all the way here and all the way here in about the same amount of time. So putting the gate location about in the center is typically a good idea to get the best filling of the part. With our small desktop injection molding machine, sometimes filling with a single gate in the center cannot actually fill the mold. That's typically the case because we don't have enough injection pressure to push the plastic from the center location all the way to the edges in both directions. In cases like that, you can use a more complicated system like we have here, where there's more than one gate. So we have a gate coming in from here and a gate coming in from there. In this particular case, we have the sprue up here, so there's different names for the different parts of this mold. We have the runners, which are these parts here, and then finally we have the gate, which is the part we've been talking about. There's also a section here which is called a cold trap. The idea of that is when the plastic first enters the mold, there's a small part near the tip of the nozzle that's not at full temperature, so we want that part, which is the colder part, to drop into here, and then once this fills up, we'll have completely hot plastic moving around to the other sections of the mold. One of the disadvantages of having a longer runner like this rather than going straight into the part is you have more wastage. So all of this plastic is going to be waste. Now you can clip it off and put it into a grinder, grind it back up and use it as regrind. That's a whole nother story and I won't go into that at the moment. The other thing is quite often the plastic, because it has to go a lot farther, will cool off sooner. And so you may need to have these larger diameter than you would otherwise. The other thing that I haven't shown here, which is a good practice, is to have this diameter here to be larger than these two diameters. The idea is you want to balance the flow. So you have the same flow rate here as well as the same flow rate there. And so that means ideally you should have the same cross-section for this as twice the cross-section of this area. And that will allow the rate of the plastic moving through here to be about the same as the rate in these two sections. As the plastic is being pushed into the mold, it's also going to be displacing the air. If the air does not have any place to go, it can result in a short shot. One of the things you will also hear is if you don't have a place for the air to escape, you're going to end up with burning. The idea there is that as the air is compressed, it heats up, and it can heat up to the point where it can start to burn the plastic. Now, I'm not convinced that is a phenomena we see on our small desktop machines. I just don't think we have the injection pressure to be able to see that. In any event, to eliminate the air and to let it escape from the mold, it's a good idea to have an air vent, which is what this is right here. This is a small section. You can see it's about 20 thousandths of an inch across, and it is only 1 thousandth of an inch deep. How deep you need this to be depends on the plastic. If you have a plastic that flows really easily, like TPUs or polypropylene, then you probably want to make this shallower, so 1/1000th of an inch, maybe even 0.5 of an inch. If you have plastics that are more viscous, like ABS, you can make this deeper, like maybe 0.02 of an inch. What I've done here is I have a section here that's not that long, that is fairly shallow, and then that drops into a much deeper section here. And the idea is that you have air resistance here because of the shallow depth, but you don't have air resistance here. So it has some difficulty getting into this cavity here, but then I can move the rest of the way out of the mold quite easily because it's a lot deeper. This has not been a comprehensive episode on injection mold design for desktop machines. It's really more about the basics, getting started. There are lots of other things you can do to take it even further, such as ejector mechanisms. There are more complicated gate mechanisms and runners. There are different gate types, etc. For most of the molds that you'll probably be making, those things are not really relevant. So what I was trying to do is just cover the basics of what's required for most injection molds for these desktop machines. I hope you enjoyed this episode. Please give me a thumbs up, subscribe, comment below, and if you're already a subscriber, you can hit the bell icon next to the subscribe button to be notified when I have a new video. Thanks for watching, and I'll see you next time.